4.6, model direct variation. Yes.
I think I forgot to turn 4.5 in.
Okay.
What?
Okay.
What do I do with it?
Well, I don't take homework late, so if you didn't turn it in, then it's a 0.
So you see.
Was that a day you were absent?
I don't exactly. Well, no, I don't think it was. I think I just forgot to turn it in.
Okay. Direct variation. 2 variables, x and y. Show direct variation, so I'm abbreviating direct variation dv, provided y equals ax and a is not equal to 0. The non-zero number a is called the constant of variation. So we say that y varies directly with x is how we will verbally say these things. So an example of direct variation would be something like y equals 3x. And we would say that the constant of variation, so I abbreviate that COV, would be 3. Now, if I had y equals 3x plus 2, this is not direct variation because it is not in the form y equals ax. Okay, so if there's something being added or subtracted in these problems, it is not direct variation. Okay, and there would be no constant of variation either. Graphing direct variation equations. So the equation is y equals ax, and in our particular case, or in general, what is the equation like in slope-intercept form? What is our equation of our line? Y equals what?
mx plus b.
Yep, mx plus b. So, in this case, we just have y equals ax. Okay, so the slope of a direct variation equation would be m equals a, so whatever that number is. Okay, what about the y-intercept? What is b equal to in this equation? 0. So there's nothing there, so b equals 0. So that means that all direct variation graphs intersect the origin. Okay, they go through the origin. If it doesn't go through the origin, it is not a direct variation graph. Kind of continuing with this. Properties of graphs of direct variation equations. So this is kind of reiterating what we have, and then I'm going to draw a picture of the different graphs here. The graph of a direct variation equation goes through the origin, the slope of the graph is A. I'm going to draw two pictures here, like two little graphs that goes with this. If A is greater than 0, meaning it is positive, it has a positive slope, and it goes through the origin, something like that. If A is less than 0, meaning it is negative, it goes through the origin going down like that, okay? So basically, think about it, negative slope for this one, positive slope for this one. All right, so the first ones just want us to tell if it is direct variation or not. If they are, state the constant of variation. So for y equals 5x minus 1. Okay, so what do we think about this one? Do we think this is direct variation or is not?
It is.
No.
It is not.
Why?
Because it has the 1 minus.
Minus 1.
Yep. So direct variation has to be y equals ax. This is not that, so this is not direct variation. So all you have to write is not dv. Six x minus 3y equals 0.
No.
So we need to rewrite it. We need y by itself before we say yes or no to it being direct variation. How do I get y by itself?
Minus x.
So I get negative 3y equals negative x. Then what? Is y by itself?
No, divide by negative.
Divide by negative 3. So y equals negative 1 divided by negative 3 would just be a positive 1/3 x. Is this direct variation?
Yes.
Yes, this is direct variation. So all you need to write is dv. And then it says if it is, state the constant of variation, which would be I'm going to say the number a, but the number in front of x. So what would my constant of variation be for this one?
1/3.
1/3. So for the problems that are direct variation, you just need to say dv for direct variation. If you want to write out the word, that's fine. And then constant of variation, 1/3. You have to say what the constant variation is. 8. 2.4x plus 6 equals 1.2 y. Is y by itself?
Yes.
No.
No. What do I need to do?
Divide by 1.2.
Divide, so I get 2.4 over 1.2 times x plus 6 over 1.2 equals y. I don't even need to divide. Why?
It's not it.
It's not direct variation. What's the reason for that?
It has another
Yep, it has another number. This right here tells me that it is not direct variation. That's all you have to have on those. Show that you got y by itself, and then if it is or is not direct variation. All right, graphing direct variation equations. So if you want to use graph paper to do these, that's fine. I'm not going to even put graph lines up for this one because they're super simple graphs. So 12 is y equals 3x. What is my y-intercept?
0.
0. What's my slope?
3.
3. So, do my graph. All right, so intercept is at 0. It's at the origin. Slope of 3. What does that tell me that I need to do?
Up 3.
Up 3, then what?
Right 1.
Up 3, right 1. Or I can also go down 3 and back 1 and do it that way. And get my line. (16) y equals 1/2 x. What's my y-intercept?
0.
What's my slope?
1/2.
So graphing it. My intercept is at 0, so it's at the origin there. What does the slope of 1/2 tell me that I need to do?
Up 1, right 2.
Up 1, right 2. I can go up 1, right 2 again, or I can go down 1 and back 2 if you wanted to. You had to do that a little bit on your worksheet that you had the other day. Some of them you kind of had to go backwards or just draw your line out to get it through the letter that you needed. What kind of slope have both of these had so far?
Positive.
Positive slope. Let's look at 18. Y equals -3/2 x. What's the intercept?
0.
0. What's the slope?
-3/2.
All right. So, set up your graph. Got my intercept at the origin. What does this slope -3/2 tell me to do?
Go down.
Down 3, right 2.
Yep, down 3, right 2. I could also go up 3 and back 2. So whenever you're doing this, if you are going to go up and back instead of like the normal way, I would always start by going the normal way first, which would be down 3, right 2, because you know that this has to make a line. So if when you go up and back, or let's say you did it wrong, you would know that your point's not in the right spot because you already kind of know what it needs to look like, okay? If you wanted to keep extending it and going down, that would have been fine too. I just was trying to keep my graph small. All right, are we okay on graphing those?
Yeah.
I feel like we did a lot of graphing practice last week, so we probably don't need to do a ton of them right now. All right, so the next ones and like the last main stuff in this section is to write equations. So it says, given that y varies directly with x, use the specified values to write a direct variation equation that relates x with y. Now, I don't normally write out all the instructions, but people tend to get confused with these ones, even my Algebra 2 students, because they don't pay attention to the instructions, okay? So, that's why I'm writing these all out. Number 30, they give us x equals 2, y equals 26, okay? They have told us what x and y are. To write a direct variation equation, it has to be in the form y equals ax, okay? Now, in every other problem that we have done, what have the variables been and what has the number been out of these things?
A.
I said what was the variables and what was the number? Y'all are just saying a letter. What were the variables?
M and B.
M and B.
Nope, these problems today.
B.
No,
They're
these
big-
problems
big,
today.
tiny. They don't
A.
have been small.
It's like 0.
Okay,
Trust. Y. 0.
look at number 12. Ignore what's written in blue. Just look at the problem. What things were variables and what was a number?
X.
X is a variable.
Y.
Y is a variable.
And then 3.
3 is A. Okay, so in this problem, though, what did they give me?
2.
26.
Okay, they gave me two numbers for X and Y. What did they not give me?
A.
9.
A. They did not give me A. I need to first solve for A. Okay, solve for A. Okay, these are like two-part problems. So solve for A. Then we are going to rewrite the equation, or rewrite the direct variation equation. Okay? So to solve for A, what I'm going to do, I'm going to plug in these two numbers. So I'm going to have 26 equals A times 2. So this just went into y equals ax. If I want to get A by itself, what do I need to do? Divide by 2. What's 26 divided by 2? 13 equals A. This is only part 1. Oftentimes my Algebra 2 students stop here. That is not your answer. If that's all you give me, you get about half credit. Okay? Because the instructions say to write an equation. Okay? So, we go back here, y equals ax, y equals 13x. That is part 2. That is your final answer. Okay? It's not hard, but for some reason, every year in Algebra 2, I have students who don't understand. I have to solve for A, then I have to write the equation. Okay? It's not hard, and their instructions actually are easier than your instructions, in my opinion. Their instructions literally tell them exactly step for step what to do, and they still do it wrong. So, I don't know. I'm just saying. Make sure you have A solved for, and then you have the full-on equation. Yes, what was your question?
Where'd you get
I solved for it.
A?
No.
It's not in the question, though. Yeah. Wait, why like...
Direct variation equation is y equals ax. If I'm given x and y, I need to solve for a. Guys, cut it out.
Yeah, bro.
Y'all are going to have questions too at some point, and you don't want everyone laughing at you. Y equals ax is the equation for direct variation. They gave me x and y, I have to solve for a. With the information they gave me, that is not written in a direct variation equation. So solve for a first, and then we go through and we rewrite it to actually get our direct variation equation. Okay, this is actually the direct variation equation here. All right. 32. X equals 15. Y equals -5. So, same thing. I need to solve for A first. So, Y equals AX. You do not have to write Y equals AX every time, but if you want to, just to get used to it, that's fine. Put in negative 5 for y equals a times x is 15. How do I get a by itself? Divide by 15. So I have negative 5 over 15 equals a. Does that reduce?
Yeah,
Yes, negative 3.
Negative 1/3 equals a. Now I need to rewrite my direct variation equation. This is just part 1. What is my direct variation equation?
Y equals negative 1/3 x.
Y equals negative 1/3 x. This is my answer right here. (34) X equals negative 18. Y equals negative 4. What do I do first?
You gotta
Divided by negative 18. Or write the problem.
You have to write the problem first. What is the problem?
negative 4 equals a
Times negative 18.
Yeah, same thing.
Okay, if you want to write y equals ax first, you can. If you want to just write the problem, like the numbers out first, that's totally fine also. So, what is a?
4 negative 4 over negative 18.
4 over 18.
Negative 4 over negative 18 is going to become positive, but technically, that is what it is. Reduce this, what do I get? 2 over 9, so divide both things by 2. And the negatives cancel, so it becomes positive, so a is 2 over 9. So then what is my direct variation equation?
Y equals 2 over 9 x. It's like a machine.
Y'all seem so excited.
We are machines.
Alright, last one. I want you to do it on your own paper. I'm going to take away how you do it and see if y'all can do it. 36, x equals negative 6, y equals 15. So solve this one out and get your equation, and we'll go over it in just a minute. Yes, you're doing this one by yourself.
Just go back up to 34. I wasn't done after you're done with this.
Yeah. All right, do we have our a value?
Yeah.
All right, what is a?
2.5.
Negative 2.5.
Same thing.
I got negative 5 over 2.
Okay, what's our direct variation equation?
Y equals negative 5 over 2x.
Yes. Should leave it like that.
I did the wrong problem.
Because if you do 2.5, you will graph your slope wrong. Okay, that's why I tell you over and over again, leave things improper. Because if I then told you to graph this line and you write it as 2.5, I guarantee you are going to end up graphing it wrong.
Technically, I'm not still right, but also not right at the same time.
I didn't say your number wasn't right. I'm just saying you should leave it like this because you're going to end up graphing it wrong if you do it the other way.
How'd you get the, for the rest of the question, I was looking at the rest of the questions and you put the y like at the
Oh.
Okay, never mind. I switched to it.
All right, any questions about this stuff?
No.
No.
I'm sorry.
What did we do?
You never know.
Really?
Why?
No, I was like,
Why?
we never know.
I went into cardiac arrest.
I thought someone was cooked for a
All right,
I was getting detention.
3 through 17 odd,
Why do we keep saying that?
29 through 35 odd, and then as some review, just to make sure we haven't forgotten stuff, 51, 53, and 55. I assure you, if you work diligently and use this time, you have more than enough time to get these problems done in class before you go home.